I'm going to do one more example and illustrate this method. Well, here's another example. The integral of x dx over the square root of 1 plus x squared. Now, here's another example. Now, the method of substitution leads us to the idea u is equal to 1 plus x squared, du is equal to 2x dx, etc. It takes about as long as this other problem did to figure out what's going on. It's a very similar sort of thing. You end up integrating u to the minus a half, right? It leads to the integral of u to the minus a half du. Right? So everybody seeing where this. However, there is a slightly better method. Okay? So, recommended method. And I call this method advanced guessing. What advanced guessing means is that you've done enough of these problems that you can see 2 steps ahead, and you know what's going to happen. So the advanced guessing leads you to believe here you had a power minus 1/2, here you have the differential of the thing, so it's going to work out somehow. And the advanced guessing allows you to guess that the answer should be something like this: 1 plus x squared to the 1/2. So this is your advanced guess. And now you just differentiate it and see whether it works. Well, here it is. It's a half, 1 plus x squared to the minus a half times 2x. That's the chain rule here, which sure enough gives you x over square root of 1 plus x squared. So we're done. And so the answer is square root of 1 plus x squared plus c. Let me illustrate this further with another example. I strongly recommend that you do this but you have to get used to it. So here's another example, e to the 6x dx. My advanced guess is e to the 6x. And if I check when I differentiate it, I get 6 e to the 6x. That's the derivative. And so I know that the answer, so now I know what the answer is. It's a 6th e to the 6x plus c. Now, okay, you could, it's also okay, but slow, to use a substitution, to use u is equal to 6x. Then you're going to get du is equal to 6 dx dot, dot, dot. It's going to work. It's just a waste of time. All right. Well, I'm going to give you a couple more examples. So how about this one? X times e to the minus x squared dx. What's the guess? Anybody have a guess? Well, you can also correct, so I don't want you to bother. Yeah, go ahead. Yeah, so you're already one step ahead of me because this is too easy. I just, when they get more complicated, you just want to make this guess here. So various people have said a half, and they understand that there's a half going on here, but let me just show you what happens. Okay? If you make this guess and you differentiate it, what you get here is e to the minus x squared times the derivative of negative 2x, so that's minus 2x. Sorry, of negative x squared, so it's minus 2x. So now you see that you're off by a factor of not 2, but -2. All right, so a number of you were saying that. So the answer is -1/2 e to the minus x squared plus c. And I can guarantee you, having watched this on various problem sets, that people who don't write this out make arithmetic mistakes. In other words, there is a limit to how much people can think ahead and guess correctly. Another way of doing it, by the way, is simply to write this thing in and then fix the coefficient by doing the differentiation here. That's perfectly okay as well.